Hey kiddos, we're going to talk today about water sustainability again. This is our second part of our water sustainability section, and so this won't be too terribly long. I wanted to split it up so that you didn't have to watch one 20-minute long video, so this should be part two. If you haven't watched part one that talks specifically about irrigation, you should jump back and probably watch that first. So we talked about irrigation in the last video and the other day in class, and so industrial water use is also a pretty big consumer of our water power. And in fact, a large part of what we use water for industrially, now there are many, many uses. Obviously, like say if you're in the chemical industry, you need a lot of water to actually manufacture the chemicals, and you might need a lot of water to clean your facilities or whatever. But what a lot of water actually goes into is actually into the generation of electricity, and I don't mean by hydroelectric power, but the way that most electrical plants actually function is that they burn fuel, okay, so say coal or natural gas or whatever, and they use the energy from that burning fuel to heat water, and that water turns into steam, and that steam is used to drive the turbines that are going to manufacture the electricity. And so there's an enormous amount of water that goes into this, and as you might imagine, this water then, in and of itself, it's not necessarily, say, contaminated or polluted, but it's hot. And so then they have to find some way to cool that down before they just dump it back out into the environment. If they don't, then we get what is down here is called thermal pollution. And thermal pollution means exactly what it sounds like. It's basically heat pollution. If you dump hot water back into a river or a lake source, it's going to severely affect the ecosystem. And I don't mean boiling water like it's going to cook everything, but different temperatures of water, as you know, have different densities. They hold nutrients in different ways. The dissolved oxygen level is different depending on the temperature of water, and so it affects it pretty drastically. So power plants obviously are then going to have to cool that water off. Another big source of that, if you think about nuclear reactors, we always sort of associate these big giant towers here with nuclear reactors. And these actually aren't really the nuclear reactors at all. These are the cooling towers. Because to keep the nuclear core, the core of the nuclear plant, the actual reactor part, from overheating and melting down and causing some catastrophic damage, they have to cool it a lot, and the cooling agent of choice is typically water, because water has a really high specific heat and therefore it can absorb a lot of heat. And so they do that, and then they run it through these cooling towers to try to cool the water back off before they put it back into the streams or lakes around it. And then the other cost of water, and this is sort of like the hidden cost, the hidden water cost, is that we don't think about a lot of the things that we have every day requiring water to manufacture them. But industry uses a lot of water just in the basic, just to come up with our basic materials that we're then going to use to make other things. So I just put a couple of quick examples up here, like refining of metals. You see here that copper and aluminum both require over 400 liters to manufacture 1 kilogram. Okay, to put that in a gallon perspective, a gallon is about 4 liters. And so that means that it's over 100 gallons of each, or 100 gallons of water to manufacture each of these two. And these are by far not like the exceptions. This is just sort of the norm. And if you think about it, a kilogram is about 2 pounds. So to manufacture 2 pounds, it takes 100 gallons of water. That's an enormous amount. To manufacture something like, say, paper, it takes about 125 liters for every kilogram. And then, of course, the water that goes into this stuff then tends to be contaminated. I mean, it's going to have, in the case of copper and aluminum, it's probably going to have some copper and aluminum ions then dissolved in it. In the case of paper, it's probably got the bleaching chemicals and all of that back into it. And so that water either has to be treated if it's done properly, or sometimes it's just dumped back out into the local stream and allowed to dilute. But that means that you then have all of those contaminants out in the water. So industry uses a lot of water. And then, of course, there's our household use. And, of course, this is what we think of a lot when we talk about environmental issues. One of the things we always want to talk about is, like, what can I personally do to help those things? And so it's really hard for you to affect irrigation if you're not a farmer, and it's hard for you to affect industry because you don't have jobs yet. But household water use, obviously, is something that we can affect. And one of the facts about this that has just sort of always astonished me is this right here. The vast bulk, sorry guys, me and the pen are having some problems. The vast bulk of our water consumption in the house goes to toilet flushing. And this is particularly true, obviously, the older your house, because older houses tend to have toilets that have really high flush rates. So they've got something like 5 gallons per flush. Modern toilets don't have anywhere near that. They have about 1.6 gallons per flush. And in fact, if you've seen some even more modern toilets, like the latest models, they're kind of cool. They actually have 2 buttons on them. One button if you're just if you're flushing liquid waste, and then a second button if you have to flush solid waste. And so obviously you're going to use a lot more water to flush the solid waste. The liquid waste is just a very small amount of water that's going to use. And that obviously would cut down on this. 41% of the household use becomes toilet flushing. The other big use is in bathing. And I think this is particularly true for us in the United States. That's where these stats are from, is from the United States. If you take a giant bath every night, or you take 2 or 3 showers a day that are 20 minutes long each, that consumes a lot of water. It takes up a lot of water. Now you can reduce that if you get something like a low flow water head and not taking baths. Typically speaking, showers tend to take up less water than baths. And if you get a low flow shower head that doesn't spit out as much water at once, then that's going to cut down on that a lot. Laundry, cleaning in one way or another, 21%. And again, that seems high, but really, I mean, compared to the other two, it's really a pretty small percentage. And there are more efficient washers and dryers that will cut down on that amount of water use. And then surprisingly, cooking and drinking is only about 5%. So, we always sort of, like, one of the classic environmental examples is like, do you let the water run while you're brushing your teeth? And it's not to make light of that obviously that will consume water that isn't necessary to use. But really, in the grand scheme, that's a pretty small amount. What's much more important is that if you can cut down on this amount and this amount, that will definitely help to conserve some water. So what can we do to reduce some of this water waste in industry and in our homes? Now, the first thing, obviously, is to recycle. And we're going to talk specifically about one way that we can recycle water in the home, but in industry as well. If that water can be reused in some way, recirculated, so like if the water can be cooled and then run back through the system, as they do in a lot of power plants, then that's actually the best, because then you're not pulling in new water all the time. To use natural landscaping, we talked about this with irrigation. If you're using plants that are native, then they're not going to require as much water, so that's going to help. To use water meters whenever you can. I mean, if you can actually monitor your water usage, then that gives you another level of awareness that might help you to cut down on that. This one, I'll have to admit, as a homeowner, I'm occasionally guilty of not doing this, is that if you have a water leak, you need to fix it quickly. If you have just a dripping faucet, over the course of time, you're going to lose a pretty good amount of water to that. And so if you can just fix those things when something goes wrong with them, then that's going to help to conserve the water. We already mentioned a little bit about low flow water toilets and low flow shower heads. That's definitely going to help in those 2 areas that are sort of the biggest, in the toilet flushing and the bathing. And then, of course, we can redesign some manufacturing processes to use less water. And there are a lot of things in manufacturing that are not necessary sometimes to use water, and just are. If the way that you clean your building at night is just to sort of hose it down, there can probably be a less water-intensive way to do that. As far as recycling, I think this is a great example, and we'll probably talk some more about this in class with some activities, but gray water recycling is a great example of how we can recycle water within the household. Gray water is the water that we use in bathing and dishwashers and sinks and laundry. In other words, the water that isn't directly contaminated with human waste, okay, is gray water. The water that actually has human waste, the water that goes out of the toilet after we use it, that's called black water. And then the water that you can actually straight up drink, potable water, that's called white water usually. So gray water is that area in between where it's dirty, but it's not contaminated, say, usually with like fecal coliforms and stuff like that might actually be directly harmful. And so what gray water recycling is, and there's kind of a big movement in a lot of greenhouses lately, is to apply a system that will basically take, the water from your sink or the water from your shower, the water from your laundry, and instead of just dumping it out, or instead of just putting it into the septic system or the sewer system, it will actually capture it and then use it for something like maybe watering your garden or watering your lawn. This is an example of a sink to mulch basin here on the side, and so you see that the sink drains out here, and then it comes out here, and some of it, yes, can go back to the septic tank or the sewer, but there's a valve here, and a lot of it can go into a mulch basin or just into like a planter to water it, because that water isn't, I mean, necessarily particularly dirty. I mean, yes, there are some contaminants in it. Maybe you've got some toothpaste in it or something, or obviously if you, took a shower, then whatever the dirt and stuff that was on your body is there. But that's different than the stuff that you would get in urine and feces out of black water that you definitely don't want to just apply on your lawn. And so there's a big movement in place to sort of recycle that. Another way that it can be recycled is that the gray water, say out of your sink or shower, can be piped back in, and that can go into your toilet tank, and then that can be the water that's used in the toilet. And so therefore that enormous amount of waste that you get out of toilet flushing is somewhat reduced because you're recycling a lot of that water. And sometimes it depends on the level of treatment. I mean, you'll need some treatment, obviously, to take some of that water and put it back even in your toilet. But the treatment is relatively minimal and is easy to do with some filtering. So that's a good example, just sort of one point example of how we can affect some changes to sustainability. So just to recap real quick here, as I think I've gone a little bit over time on this video. So sustainable water use, a couple of ideas in general. It would help if we raised water prices and subsidized conservation. No one's really happy with raising prices, but if you raise the prices, people value it more a lot of times. I like to think of Apple products in that case. I mean, Apple products always cost a premium, but you always know that you're getting a quality product. You know the value of it, and that same thing is going to be true for water. Subsidized conservation, so subsidize technologies and stuff that help us to do that. Maybe subsidize some gray water recycling, subsidize some different ways of irrigation, instead of subsidizing the water prices themselves, which obviously is counterproductive, as we talked about. Don't deplete the aquifers. Do whatever we can to not pull as much water as we can out of the aquifers because we're not refilling them at the rate that we should. Protect the natural systems that store and cleanse water. This goes back to ecosystems. We want to keep wetlands and areas like that around because they're going to serve a valuable purpose in storing the water and filtering the water for us naturally, and it saves us obviously enormous expense. We should make sure that there are proper agreements as to the use of water. So we want to make sure that countries, states, counties, whatever, that they have agreements as to how that water is going to get split up, and that those agreements include the ecology of the area as well, not just the human use of it. And then we should do everything that we can to preserve water quality, and we'll talk about this much more later, but this obviously goes into the idea of not polluting the water sources that we have just because that's the easiest thing to do. Okay, so hopefully that gave you some good ideas for sustainability, and we'll obviously go through a lot more activities when we get to class.